In math, equality and balance is one of the most important concepts that we can have. And it's one of the things that we always have to keep in mind and always have to observe. When we talk about equations, the model that we're going to use is balance. So we're going to have a left side of the balance and we're going to have a right side of the balance. And we're going to have to show that the left side and right side start balanced and stay balanced. And that's really important. And most of the physical properties that balances have are shown algebraically. Now, we're going to end up using a balance to solve equations, but the first part that we're going to look at, and the part that we're going to look at today, is just looking at the properties of when things are balanced or when things are equal. And there's some properties that we can use. If we start with the equality, a is equal to x, or in other words, a is the same as x, and we can say that a plus b is equivalent to, a plus 3 is equivalent to b. So this a plus 3 balances b. And we can also say that b is equal to z. So these are just some things I'm just stating. You know, these are not based on any particular facts, but just our definitions that we start with. We can start with these definitions and come up with new balances. So I can come up with new expressions that are equal to b. So I have b here. B is equal to a plus 3. B is equal to z. I can make an expression equal to b by starting with this balance. So I will start with b, and that's equal to a plus 3. And since a and x are exactly the same, what I'm going to do is I'm just going to replace the a with an x. And this is also an equality. This is balanced. And that's all we have to make sure we do, is we need to make sure that we keep this expression balanced. And by replacing a with x, I keep it balanced. I can do the same thing here. I have an expression for z, and I need an expression for z that includes x. So I need an x on this side. Well, I start off with b and z are equivalent. But I need to replace this with something that has an x in it. Well, I can replace the b first of all with an a plus 3. So that's what I'm going to do first. I'm going to just say that a plus 3 is the same as z. And it is balanced, and that's really all I need to keep track of, is I just need to make it balanced. I can also see that a and x are the same thing. So what I can do is I can replace that a with an x. So I end up with x plus 3. Instead of a, I'm replacing it with x, and that's equal to z. So now I've satisfied this condition. I need to write an expression for z that includes an x. Well, there it is. And I know by doing equal replacements, this is balanced. And that's the most important property that we're dealing with, is balance. So there's some properties of a balance that we're going to look at. One of the properties is adding and subtracting. So property 1 and 2 are, property 1 is adding, property 2 is subtracting. And these are the properties I'm going to refer to when we do some exercises at the end. And adding and subtracting means that I can add some amount to the left-hand side, and as long as I add the same amount to the right-hand side, this is going to stay in balance. And again, this is the idea. We want to make sure we just keep everything balanced. I can take away 5 kilograms from this side and take away 5 kilograms from this side, and by taking away 5 kilograms from each side, it doesn't, although I don't know what's inside these boxes, I know that this is going to stay balanced. Okay? So in this example here, it says, what if we add 8 kilograms to both sides? So I'm going to just say that that unknown box, these boxes are x plus 5, and that's balancing 13. If I add 8 kilograms to both sides, I'm going to add 8 kilograms, so I'm going to get 13 here. Well, that's not balanced yet, but if I add 8 kilograms to this side, So I do plus 8 plus 8, and then notice I'm doing all my math vertically. This new balance is balanced. Okay? If I start with the same balance, 2 unknown boxes plus 5 kilograms equals 13 kilograms, and I subtract 2 kilograms from both sides, what I'm going to end up with is I'm still going to have these two boxes. Instead of 5 kilograms, I'm going to have 3 kilograms on this side and 11 kilograms on this side. Again, notice I'm working vertically, and as long as I take off the same amount from both sides, if it starts off balanced, it ends up balanced. So the property 1 and 2 are about adding and subtracting. If we can add and subtract the same amount from both sides of the equation, we keep things in balance. And that's the key idea. Are we keeping things in balance?